Thank you, everyone. So I'm just starting. So thank you, everyone, for joining this event. Good afternoon, good evening, or good morning from wherever you are. My name is Reenu Mohandas, and I would like to welcome our audience and speakers to the 14th Early Career Talks event organized by IEEE UK and Ireland, Women in Engineering Affinity Group, and the Intelligent Transportation System Society. The theme of today's event is Towards Sustainable Mobility, Intelligent Transportation, Engineering for a Greener Future. This session will be chaired by Dr. Nagham Saeed, Associate Professor, Electrical and Electronic Engineering, University of West London. And this year's session will be co-chaired by Gunny, Dhadyalla, Network Director, AESIN. I would also like to mention that the presentation recording will be broadcast on our IEEE section website and our YouTube channel. We will take questions from the audience after each presentation. Please mute your mic during the presentation of speakers, and please don't use your camera while they are presenting. If you have any questions that occur during the talk, please don't, and if you don't want to lose track of, please do type them into the Q&A chat box, and we can address them at the end. To target the question to the right speaker, you may use their name or their talk order. We will address the questions at the end of the presentation. Now I will hand over the session to Dr. Nagham for the opening.
I will share my screen. Can you see my screen?
Yeah.
Yeah, thank you. Can you see my screen now? Sorry. Can you see my screen?
Yeah.
Yes.
Yes, we can.
Yes,
yeah,
perfect.
we can see the presentation. Yeah.
Thank you very much. So welcome everyone, and thank you very much, Reenu. I'm Nagham Saeed, the 2023 IEEE UK and Ireland section Women in Engineering Chair, and I'm also one of the ExCom committee for the Women in Engineering for the section. And as well, I'm also one of the ExCom committee for the Intelligent Transportation System Society, and also looking after women in engineering activities and younger professional in that society. I'm also the vice chair for the section 2025-2024, and I will become the chair 2026-2027. So I would like to extend my heartfelt gratitude to all the speakers and the attendees for taking part in the 14th Early Career Talk. This is an opportunity, as I always say, to just to know about the state of art in technology and science, and listening to young professional careers and researchers who are doing really great in their job. And we are so proud to have them on board to talk about intelligent transportation system today. Before I start, I would like to say congratulations. Tomorrow will be the International Women's Day, and this event is part of our activities to celebrate that special day. This is not the only event that our section is doing, but also yesterday we had also our current chair for the Women in Engineering, Princey, with the Ruth, the vice chair, also holding another webinar session talking about the senior elevation for the IEEE member, and answering the questions for members who are interested to become a senior in this special community. So who are we? We are part of the global IEEE organization, Women in Engineering. Our aim is to promote women in science and technology and be a role model for young girls and encourage them to choose engineering as a career. So for us, we are actually in more than 125 countries. We have more than 37,000 members, and we have many affinity groups all around the world, around 1,100. And we are so active, and we create a lot of events, more than 4,000 events, trying to create a balance at work. So as I mentioned before, we held a lot of activities and they are different. We held seminars, we held conferences, we go to schools, we talk to a young generation, we promote engineering as much as we can, especially for young girls. So what we offer to our members, we offer them leadership opportunities, asking them to support us in our events and have some leadership roles and organize activity with us, which also will help them in their career. And we, as I mentioned before, we held two types of events, either empowering event or pure technical events, workshop under joined with conferences or joined with societies like what we are doing today. We are holding this event joined with the Intelligent Transportation System Society. We also offer mentorship to our members to support them through their career, and we pair them also with our colleagues to support them and give them advice how to go if they are asking for any advice around their careers. So, for example, this is some of our activities that we did 2 years ago for the International Women's Day at the 8th of March 2023. Well, those are our ambassadors, and maybe Reenu, she can link to one of her colleague at work now who's really doing great, and I can see these our ambassadors from 2 years ago, and each one of them, she did really well in her job career, and I can tell the difference from 2023 and 2025 now. As I mentioned before, we held a lot of events and a technical session and special sessions, which have been sometimes merged. So we will have the empowerment factor beside it's also purely technical one with a lot of panel discussions for our members. And this one, which we did with the coins conference, was last year. This is another actually initiative called Challenges and Opportunities, which is also something that we are very keen to do it annually. And this year we will have it also in London with ASCA's conference. And we will talk also about the technical challenges for the industrial IoT. While this one, the one that you saw, we looked at it, it was like around women leading in technology and reflecting around that aspect. Again, as I mentioned before, we host a lot of events. So this one was looking at sustainability and how to empower diverse force and to shape the future. So that was in University of Glasgow, and you can see Sana in that picture as well. Of course, that was joined with the society chapter and younger professional and antenna propagation societies. Also, we heard, and this is another example, working with ITSS, and we had a very nice workshop related to intelligent transportation systems, and looking at how we can initiate around sustainability and net zero. Working also with younger professionals and supporting them with webinars. This is also something that we dedicate ourselves to do. And this is an example, working with younger professionals and giving some empowering talks. So I will stop because really I'm keen to listen to your presentation, but before that I would like to listen to Reenu and what she's going to talk about their activities as a student branch. Thank you very much.
Thank you, Nagham, for the wonderful presentation. Now I would like to say a few words about the activities we have at as a IEEE ITS student branch here in the University of Limerick. Now I will share my presentation. Hope everyone can see the presentation.
Yes, we can.
Okay, thank you, Nagham. So I'm Reenu Mohandas. I am a researcher in the University of Limerick. I'm also working, I'm currently the secretary of IEEE student branch, but I'll be stepping down soon, but then I'll be concentrating more on the IEEE ITSS chapter, being the chair of the chapter for the UK and Ireland session, the student branch chapter we have at the University of Limerick. In this presentation, I would also like to talk about how we combine the three entities, the Intelligent Transportation System Society, UK and Ireland chapter, University of Limerick, and the whole IEEE as a framework to promote and come up with impactful events from as a part of this unit of ITSS. So the the University of Limerick IEEE Students Branch was approved in October 2023. So we are a fairly new branch, but then upon the approval, we have started an OES chapter, Oceanic Engineering Society chapter in November 2023. And 1 year on from that, we got the approval for ITSS in November 2024. Our first event was an impactful event, Impact of AI in Science and Engineering. It was a panel discussion from multiple personalities from different walks of life. We had an industry partner, we had people from academia as well. It was a very impactful event attended by more than 30 people. Then we have the second event was networking and a virtual talk event, which was the first event from the ITSS chapter. And it was also a very successful event. And the next event, now this is the picture that I have about the panel discussion. It was very successful. And then the next event was IEEE Malta Robotics Competition. This is very, so this event was about this is the networking event we had. The IEEE Malta Robotics Competition was very important to our student branch because we won the Malta Robotics Competition, and thus we have the IEEE Student Branch of University of Limerick. We have our identity as part of the in the area of UK and Ireland section in the region 8. So it was a very strong event from our part, and we are looking forward to more events, and we are conducting more REMI conduct this time, and more robotics events from our branch this year as well. Now I would like to talk about IEEE ITS, the Students Branch chapter. We have recently conducted an industrial visit on 18th February. We have a DICE research group in our own university. This is where our university comes with for help from the student branch. So the research group have industry collaborators, Valio, JLR, Provisio, and FMCI. We had an industrial visit to their facility. It was a very insightful event. We get to see and to see the details the engineers go into to implement all these AI-based and intelligent transportation into everyday vehicles that come into use. We got to chat to the engineers from all these facilities about all the autonomous vehicles and various intelligent transportation algorithms that are used. Then we had the industrial visit we had from engineering students and computer vision and cybersecurity students. These are industry partners. The next event that we have immediately is a talk from Professor Alexander Braun. He is from the University of Düsseldorf, Germany, and his area of research is camera systems and optics for autonomous driving, and we will have the invited talk on 13th March 2025. This is a very recent upcoming event for our branch. And we look forward to more further events for the ITSS Students Branch chapter from the section. With this, I have the update of all the upcoming events there, and I would like to also mention the agenda for today's event. Now we had the talk from Nagham, and next was my presentation. Now from this, we'll go on for the speakers. We will go through all the speakers one by one, and then we'll have a presentation from Gunny, Dhadyalla, and then even closing by Nagham Saeed. Now I'll stop at this slide, and I would like to invite the first speaker, Sana Hafeez, for her presentation. Thank you.
Thank you. Sana, can you please share your slide and start? Unmute yourself as well.
Is my screen visible to you now?
Yes.
Yes.
Okay. Good morning, everyone. It's my absolute pleasure and honor to be the part of this 14th early career talk on Women Engineering UK and Ireland chapter. And first of all, I would like to thank all the organizers and chairing sessions committees, a member, and happy International Women's Day to all of you. Before we going forward, I would like to introduce about myself. I am Dr. Sana Hafeez, and I am working as a postdoctoral research assistant in Queen's Mary, London, with the collaboration of Imperial College, King's University, and with the University of London. And same times, I'm working as a research assistant in University of Glasgow with the partnership of Glasgow Caledonian University and University of Coventry, where I'm working on Charter Hub. My academic journey has taken me across multiple countries during my research collaboration in last 3 years. And I just finished my PhD recently, 8 months before. My PhD is focused on 6C-enabled intelligence communication for blockchain-assisted UAV network design and optimizations, where I design few solutions of cybersecurity and quantum computing, AI, federated learning, and just same like the optimization techniques. I recently got the Global Talent from Royal Academy of Engineering. And for my MS, I did my master's in Internet of Drones, that is from Comsat University, Islamabad, Pakistan. And my bachelor's I did in software engineering from Must, Islamabad. Throughout my careers, I have been actively involved in different diverse fields. Means my whole area is not stuck to only one computing field. I came from software engineering, then IoTs, then cyber side, and now I am working with the healthcare and indoor breath monitoring. During my PhD, I had gotten this opportunity, and I feel I was so fortunate to go to the Canada to doing the research mobility with University of Calgary. And there I did the drones communication in security and privacy with the digital twin. And right now I am involved with King Fahd University of Mineral and Petroleum, Saudi Arabia, where I am working on quantum computing sites, how we can secure the healthcare deliveries in AI expected solutions and with their work. Beyond my academic contribution, I am honored to be a part of IEEE member, IEEE Women Engineering. I host sphere session chairs like IEEE WCNC, IEEE VTS, RSSI, and now I'm also going to host an upcoming conference session, which is in Glasgow, ICSDC in March. And one of my defining experience during all these 9 to 10 years was when I was selected for commissioned as a lady officer in Pakistan Military Academy after my software engineering degree. And there I learned lots of things about struggle, discipline, resilience, and how to be adaptive. These qualities, I think, that are the best in me to continue to drive me in the research of different fields, diverse fields at the same time. So today my topic of discussion is ensuring the UAV security. As we know, we all are going from 5G towards 6G. And now everything is transferring from triangle like URLLC, embedded mobile enhanced telecommunication, or massive machine types to the hexagon structure, where we will work on hypersensing, biosensing with robotics, and virtual reality, holographic communication. So for that, definitely in intelligence communication, one of the big role play is would be the of drones, because drones are not only works in the healthcare deliveries, they are also doing for parcels. They are working with civilians, with military operations, even though in the wedding, photography, videography, and for intelligence communication. And what if we consider that in future, let's suppose there is a disaster happens, or there is some gap in the invention, like what happened during the COVID. And sometimes we think there is lots of areas in UK which are no-fly zone area, but same time some areas where are island, highland, and there is no transportation. And lots of patients who are suffering with cancers and allopathic patients who are taking their medicine, but they can't go to so far. And there are some mental stress and heart attack, severe heart attack, and also with the chronic patients. So how we can deliver the drones delivery in that areas which are dense population, where there is no internet of vehicles, or they are cost effective. So for that, I designed the whole solutions on which my whole PhD is based on. That was the problem statements that how we can provide the intelligence and drones delivery in the healthcare. So the first scenario which I want to discuss is when there is a disaster already happens, and all the base stations, as we can see in the pictures, the base stations, the internet of vehicles, there's a flood is coming, some signs of earthquake. So everything is damaged on the earth. So how the UAV can come to play as an intelligence communication, same times to provide the healthcare deliveries, like for the parcel deliveries. For that, I design drones assistance UAV intelligence communication with the blockchain involvement to secure the deliveries, and also to register all the drones clusters or flocking on drones. Like basically this work is inspired by bioflocking algorithms, that how the birds are flying in the nature. So that is targeted especially on air-to-air, air-to-ground communication when the links are disconnected. So how we can provide the resilience connectivity and AI-driven security to provide the rescue and supply chain deliveries. So in the future of work, as we know now, we are shifting towards quantum cryptography. For quantum, definitely we need very strong hardware, cost-effective solutions. So as far as we are running towards 2030, so all these things are going to shift to the quantum machine learning, quantum digital twin, quantum blockchains. So these can be the future work of this work. A second scenario is also same, but it's a different in terms of authentications and for secure how you can do the security for the drones or intelligence communication when they are decentralized and distributed across lots of edges. Either it's a cloud or also they are working in the air to secure the sky. As we know that during the drones operations or when the drones are hovering in the air, or there can be lots of cyber attacks or cyber thefts can happening to hijack the drones, even through their data telecommunications, their transferring of data communication. There is also a risk that someone can hijack it or some can destroy it. So the blockchain ensure with quantum, it ensures the authentication without the central authority. In that intelligence communication, you don't need a central authority to hold the whole infrastructures. But when you distribute it across the different zones, or then you can do it with the quantum using very confidential keys to exchange your data across your that drones or that areas or entities which are already in a group or already registered with that quantum keys. So this work can work to improve the efficiency, reduce the cost, and enhance the cyber resilience, which is very useful. Either we are working suggesting about the civil or military operations. The third one is BIRDS, which is also inspired by blockchain-empowered, immutable, and reliable delivery services. So in that, there is a different types of blockchain consensus in which we are come into play. Then we make the one novel contribution that how the blockchain can work as a blockchain for the proof of competency, means on the base of competency, how the drones can deliver any types of delivery for that areas before we are using the quantum algorithm, so it can find the optimal path for us rather than to send the drones on different areas. It's already detect that which area is more suitable for which drone according to their battery power, according to their whole data provide, their weight and energy efficiency. So here are a few results which I also mentioned here. You can see that our results shows that these are the most efficient and for last mile delivery especially, and it's also take the less time to deliver the data. Currently, there is absence in secure and traceable UAV communication because everyone is working on UAVs, drones, intelligence communication, but it's very challenging for us because now we are going to the robotic sites and holographic sites. So the security and privacy is the primarily concerns for Internet of Vehicles, Internet of Drones, and all the intelligence communication. So if we have the unauthorized drones, so what can be the happen? Definitely it will cause the posing the security issues. It can also cause data integrity concerns and theft, hijacking, denial of services attacks. This work is recently I have submitted with King Fahd University of Mineral and Petroleum, that is purely based on quantum AI, and there we are also targeted about some desert areas, some sea, oceans, seashores, and dense populated areas. So there are basically three layers: air layer, communication layer, and quantum layer. So after securing all the data, we use the quantum key distributions because you know the difference between the classical quantums and now the quantum is that it works only on 0 and 1. But the difference between bytes and quanta bit is that it has more flexibility in terms of probability, either 0 or 1, or we can combine with their superpositions, entanglement, or interference control. So these are basically, the whole paper is mathematical modeling of quantum, that how the quantum can secure for intelligence communication with different infrastructures. And why does it matter for UAV security? Because the cyber crimes or criminals are involving with the arrival of quantum, because they are also very sharp in terms of hijacking, and it becomes a very difficult challenge to encounter. Password, secure communication, even the blockchain-based authentication, that is not 100% secure because they can also be hijacked. But if we use the quantum, so quantum, it works like the resilience also for adaptability solutions for quantum key contributions that used in the laws of quantum mechanics, quantum physics, and which are difficult, impossible to break, or the encryption keys. So now imagine like applying quantum security to UAV networks. What can be the opportunities of that? Because it's give the 100% security to the military UAVs. Because there are lots of military UAVs which are going to monitor the areas of different fly zone, where there is no geofencing, sometimes in the wars, sometimes in disaster reliefs, to provide the hostile environment. So autonomous UAVs in smart city can also operate without the fear in the cyber threats or attacks. So how the drones, AI, and quantum work for the secure healthcare? So if we are considering in healthcare, in telecommunication and sensing, the basic difference between 5G, 1G to 5G and 6G is that in 6G, we are also working on JACAS, joint communication and sensing. So we are not working on sensing side only, we are not working on communication side only. When we are talking about healthcare, so or any other scenario, we are targeting basically both joint communication and sensing. So when we are going to intercept both technologies, definitely there are more chances to steal of the data. And you know, healthcare is a very critical this time for the critical technology to be considered on, because there are lots of indoor breath monitoring solutions, indoor health monitorings for the telehealth are going to play. So for this, we are designing a secure secure quantum-based formal verification techniques with the Markov models. And the scenario is, let's suppose in future, like 2030 to so on, there are multiple patients who are sitting in one room and they are doing their breath monitoring. So few are doing their online streaming, few are working on the tablet. So what if there is someone who can hijack their data, who can send their malicious information? So for that, we are designing a formal verification techniques. If you see on the right side, I designed the whole data sensing with where the patient is doing the breathing with two US RPCs, and there is a communication size. We are using the DANI, direct artificial noise injection. There is also a risk involved, reconfigurable intelligent surface. After getting all the data, it's going through the formal verification techniques, PRISM model checker, where we can highlight what can be the security risk in terms of probability. And for the quantum size, we are going to secure our IoT devices, because in that there are multiple devices are monitoring. If you check the left side of the screen, you can see there are different ages of patients are involved in that. And the lower one on the left side is showing how the quantum keys can exchange with each other between the data and patient, TX or RX or LS or both. In the future work, luckily, I also got selected to work with the Queen's Mary, and we are already working on 6G Funds project that is also sponsored by Cheddar. And in that project, we are also working on quantum, but we are going to work on that field which is not explored yet. That when there are lots of IoT devices, base stations, and multiple users, we are also considering their hubs, labs, maps, and also satellite communication, which is the novel of this time. So how we can secure our whole sky or satellite communication. As we know, there are some future works or conclusion which I want to conclude from AI to blockchain, then quantum, and what is the advance in quantum. So in advance, we can use in the sensing or intelligence communication, quantum machine learning, which is very faster, because smarter AI models are developed, and because of the cost and computational power, as we already know, IBM and Google is already working to create the clusters and quantum machines to work in the future. It can also enhance the pattern recognition. It can also work with threat modeling, anomaly detection, real-time AI decision making, and which provides the synergy for UAV security to involve with AI quantum. Because AI detect the cyber attacks, quantum cryptography, and GPS spoofing. There are also some more very novel quantum algorithms where we are working on the conventional or the basic traditional quantums, and we are make them adaptive techniques by using the drone's path planning, optimal solution, energy providers, and resource allocations, and also for 6G enabled networks. Thank you very much. If you have any questions, feel free to ask.
Thank you very much. Thank you very much, Sana. Very interesting
Sorry,
research
I
field.
speak back to back a lot because I thought it's a shortage of time and I need to cover some novel areas, means on which the researchers can do work in future.
Yeah, no, it was really, we thank you. The message was delivered. Thank you very much. Again, do you have any question for Sana?
Yeah, Sana, thank you very much. Very, very comprehensive. Yeah, there were so many things in there that you think, wow, that's amazing how much ground you've covered. I had one or two questions. So, of course, our background is automotive and vehicles on the road. And I guess there were two questions. One thing the industry, automotive industry, worries about is when you start to have automated vehicles and you rely on connectivity, that there's more risk introduced, because if you have a connected system that you're relying for controlling a vehicle, then the denial of service or the man in the middle attack is a very easy attack to stop your function, right? So and of course on the road it's less easy because the car's not going to fall down, but from the skies, UAVs and other airborne technologies. What's your view and in your research, about addressing this thing about the basic attacks here? As I said, the denial of service type attacks and the impact, because the medical application is a critical application, as you said. It's a safety and health related one. Does your research or the industry considering what happens in these situations and how you overcome them?
Yeah, on that project which I am working, because under the UK government projects, all are was for 1 year only. So in 1 year, we can't do just it with the real-time monitoring of intelligence drones or intelligence vehicles. But I also I'm just shortlisted for AI drivers, which are the industry in London, and they are working on smart and intelligence communication. So I also give them the idea, because they are only working on MATLAB simulations and AI and machine learning. But if we're considering, that's why I chose my topic today for quantum, because when we are talking about the synthetic data on Monte Carlo assumptions, we can justify with AI, with federated learning, split learning, reinforcement. But for the real time, as you told me, that when we are considering about the billions of devices and also with the congestion of Internet of Vehicles, then the basic attacks like DDoS attacks or man in the middle, we can justify them with the quantum techniques. For quantums, it can work. So we have a few suggestions and we are working on them. But before applying quantum, we are first going through the threat modeling techniques for applying adaptive threat modeling. So I'm just designing that framework on which we are working, like adaptive stride model with dread model, where we are targeting about 5 attacks. And then we will compile them. If it give us the good risk assumptions and all analysis, then we will apply it on quantum.
Okay, yeah, very interesting. And just one more question, Nagham, before I pause. You talked about threat modeling and, of course, quantum now. What do you think the role is of AI, LLMs in threat modeling itself? Do you think there are some already work, maybe there's work already going on, but do we need to be more adaptive or forward-looking in how we do threat modeling, considering that the landscape and the threat surface is increasing? Do we need to approach threat modeling in a different way using AI? And what are the risks with doing that, if you have any ideas?
Yeah, as in 6, we are shifting from triangle to hexagon. So we need to consider risk. We need to consider about the AI. As AI is good in terms of positivity, we can take lots of things. But when we involve AI in this field, then there are attacks of cyber attacks are more. So we also need to take care of them. And as you know, for quantum, it's very expensive and very highly cost. We can't apply quantum on everything. We need a very HPC clusters and very high powers, and also time too, because for a good project, at least 2 to 5 years are okay to justify for any project. So when we involve quantum, the best thing to apply the threat modeling before that is, rather than to waste your time, money, and also cost, it's better if we apply through them like we do in the virtual replica and digital twin, but the same scenario we can apply in threat modeling. And if we do that to detect the anomalies and what can be the future risk analysis and countermeasures which we can use to deploy the defensive attacks. So it's more better. That's why we also decided for, because we are also going to justify the real-time SAT communication, HAPS, labs, Internet of Vehicles. So we are going through the first step on the threat modeling, then AI if we need it, but the basic scenario would be the quantum.
Okay, thank you very much. Thank you. And thanks, Nagham.
Thank you. I've got one question for you, Sana. It's about cybersecurity and how so does cybersecurity in healthcare UAV network affect 6G?
As I already discussed about, there are some critical connections between the privacy, security, and healthcare. Because when we are securing about these critical IoT devices and with disaster response, either it's for healthcare, linking the things, especially in the healthcare, security is more important because there are lots of elderly patients who will do their indoor telehealth operation by themselves. There would be no one who will just check them, like for the breath monitoring, for heart patient, for ECG. And also for in terms of remote teleservices or emergencies, a security vulnerability in the healthcare that could lead to data breach and also attacks if we consider about AI diversity attacks, because right now Wi-Fi is available in every device, in every home. So there are more chances to attacks of the AI with these hackers. And if they're considering 6G, the more secure solution for right now is quantum with involvement of blockchain or quantum with the digital twin.
Very interesting.
Yeah, because 6G is not the finalized yet. It's also going to develop.
Yeah,
so
I
hopefully
agree.
we will get some new infrastructure until 2030.
Yeah, I agree. Thank you very much, Sana. Before I hand off to Reenu, I would like to welcome the chair for the Intelligent Transportation System, Milan Lovak. Hi, Milan. Thank you so much for joining. And please, if you've got any question, please unmute your mic and ask. I will hand off to Reenu.
Thank you, Nagham. Thank you, Sana, for the beautiful presentation. Now we'll move on to the next speaker, Assemgul Kozhabek, and I welcome Assemgul for a presentation.
Thank you very much. Can you see my presentation? Just to check. Okay, thank you very much. So today I thank you for the opportunity to present my research for the audience of IEEE Women in Engineering. It's a good opportunity for me, and I will be very glad for your feedbacks. So today I'm going to present you the part of my PhD research where I studied static structures of the road networks and dynamic part of the road networks like congestion. So today I'm focusing on the first part. So for that we studied 35 road networks from different populous cities worldwide. And we applied network science here to study the static structures of the road networks. So when I say we apply network science, I want to clarify here that we see road networks as a complex systems, and it's represented as a graphs, which consist nodes and edges. When I say nodes, it's the intersections or junctions in the roads, and the edges are the streets or roads that connects these two different intersections. So today, all of the researchers are presenting on the same topic, which is the sustainable mobility and transportation. Before starting presenting my research, I would like to give a personal story why I came to this research. So originally, I'm from Kazakhstan and the city of the Almaty, which is one of the biggest cities in Kazakhstan with 2 million population. And I used to travel in my primary school and secondary school 3 hours in a day to commute from my home to the school. So, and while I was spending 3 hours in a day only for commuting from one point to point A from point B. So I was always thinking like how to make this life easier for people, so they don't spend lots of time on the traffic, and so they can. And I saw that my parents, they also spend lots of time on the traffic. So I was thinking, like, we could have used this time in better way, having a quality time. So this was one of the reasons why I came to study the congestion and in general urban road networks. So this was one of the personal motivations. And on the other hand, if we come to the scientific reasoning for that, we were seeing that there is a growing urbanization worldwide, and we see that the growth of the vehicle ownership, and we also see the consequences of the congestion, like environmental, economic, and other psychological consequences of it. So this drove me to study, to come to this field. So objective of my research was to analyze the static structures of the urban road networks from multi-scale, from macro, meso, and micro. I will give details further on. So as I mentioned, from childhood, I was sure that this area is interesting for me. So that's why I studied my bachelor's in mathematics and computer modeling. And then I did my master's degree in engineering business management, but my dissertation was focused on transportation capacity planning for big events and how to avoid congestion while we're hosting these big events. And on my PhD degree, I was studying the urban road networks. So currently I'm working as a research associate in University of Ulster, but I'm working with different types of data. So coming to the static structures of urban road networks, since my PhD was funded by Bournemouth Council, City Council, while I was having the initial meetings with them, I understand that the transport planner somehow doesn't have the deep understanding of different urban road networks and how to analyze them. So that's why I came up with this proposal to them, where we look at the urban road networks from macro scale. We have 9 different metrics to analyze it. This all comes from the network science, where we look at the robustness and degree diversity, transitivity, and efficiency of the network. And then from mesoscale, we looked at the different communities in the road network and is there co-periphery structure in the road network. Then in microscale, we looked at how all these nodes are distributed over the road network. So the key highlights, when we looked at them from the macro scale, we found out that some metrics have a high positive correlation, like meshness and the clustering coefficient and the robustness, and while other metrics have negative correlation. And in general, what we found that the road networks that are usually robust, they are comes as more efficient one. And we also found that, as you see here in radar diagrams, from all these 35 road networks that we studied, and the smaller road networks, they perform better. They have higher results in all these 9 metrics comparison to the bigger road networks. So this was one of the key findings. Then when we looked at meso and microscales, we found that the static road networks, they have a high number of communities and there is very low sign of co-periphery, which means that they are polycentric. So it doesn't mean that they have one city center and all of the others treated as periphery. They have different cores that can be treated as centers of the communities and the peripheries. So this findings from mesoscale. So when we looked at the microscale, we found out that degree distributed in T-shape. So most of the streets are follows T-shape. And when we looked at betweenness distribution, we found the strong power law fit. So when we say betweenness centrality of the node, it means the nodes or intersections that act as a bridge that connects different nodes in the road network. So we found that if you look at the chart that follows power law here, you can see that there is very few road networks that connect other nodes, the junctions, and there's lots of junctions that doesn't act as a bridge to connect other road networks. And we looked at the closeness distribution on the other side, and we see that some of the road networks have most of the road networks have binomial distributions, but some of them are left skewed, which means that there are some nodes that are not really connected with the main roads that in the city. So by closeness centrality, we mean how this node located close to other nodes. So there are some nodes that are apart from the main part of the city. So in conclusion, I would like to say that all this help us to better understand the road networks. Then when you do transportation planning for the city, it gives you the opportunity to do informed decision making. Also, if we come to my personal research goal, so I would like, my research goal was to study road networks, and on the other hand, on the I was also looking at the spread of congestion, which is another topic to discuss. So, and if we come back to the big picture, the reasoning why I am doing this research is I would like people to have some more quality time with their families or the close ones rather than stacking in the traffic. So the other references, this study was published in the journal Environmental and the Planning B, Urban Analytics and City Science. So if this talk was interesting for you, you can go there and check the detailed findings. Thank you very much.
Thank you. Thank you very much, Assemgul. Gunny?
Thanks, Assemgul. Nice and clean presentation. Very interesting, and this topic is a big topic, of course, across the globe, especially when you talk about urban complexity. And from my little understanding, every large city or urban environment has a different dynamic. Of course, you showed Calcutta there, which is particularly exciting. London itself would be different. Paris is different. Do you see these? So I have two questions. One is, do you see this difference also an important factor in the modeling, that actually different countries and different implementations in these large cities look different in the way they work, the vehicles that are there, the roads that are more or less populated in your modeling?
Yes, there is another study which I did where we looked at the spreading of the congestion in urban road networks, and there we found that there is a similar pattern as epidemic spreads, like SIR model, susceptible, infected, recovered. So we found out that it has the similar pattern. And we included as an input the road network itself, the adjacency matrix of the road network. But in that study, we had as an input, we did this work on two cities in Los Angeles, in United States, both of them the big cities, but unfortunately we didn't have a data from other cities to compare. But I'm sure that in my recent static part, we see that there are some tendencies that can be seen in populous cities, no matter in which country it is located. And also in this paper, we also did a comparison, because most of these populous cities come from China or India. So we did also the cross comparison of these two countries, and it also can be found in the paper.
Okay, very interesting. Yes. And then I guess one final question is, of course, we have as part of the work we do in AESIN, a group that's looking at connected vehicles and the flow of data from vehicles to the infrastructure and the impact it can make. I don't know if in your studies you will get a chance to do this in your research or you're already doing this, but once you've modeled what the urban environment looks like, you also then want to see how it can be influenced. Let's say if you're a road operator, so in the UK we have the national highways who operate the large trunk roads and the motorways. If they want to manage the flow and the efficiency of traffic, are you modeling in, and how can you model in the use of vehicle data to start to influence those models to show the impact it can make?
Actually, we used for my study, we used the data that collected in intersections of like the traffic speed. Like we were using like where we can say this specific node is congested when the traffic speed goes low, below the average. So we were using that one for the peak times. So that was used in my research that was collected from these intersections. But I didn't yet apply the data that was collected from individual vehicles.
And this data you collected is from roadside infrastructure sensors or from
Yes.
vehicles? Okay.
From
right.
the sensors, yeah.
Okay, got it. Okay, yeah, very interesting. Thanks very much for that,
Thank
Assemgul.
you.
Nagham, back to you.
Thank you, Gunny. Yeah, I agree, Gunny. Very interesting. And just a follow-up from Gunny's question as well. You created your model for traffic congestion and how you could recycle this model in a different city. You mentioned that your project was sponsored by that council, and if you want to recycle your model for a different city, how much will left from your model to use the same, and what other parameters you might need to create the model?
Thank you for the question. This model can be applied for any city that has where we have data of the road network when it was abstracted as a graph. So I can do it myself as well if they don't have it. So it's easy to do when you see whole city as a graph that consists node and the edges. So this is one of the input for the model. Another input is the data that was collected from the road infrastructure, that the average traffic speed for the certain period of time. So if I have these two data sets, so it can be applied. I can apply my model for that. So they can see when the peak period of the congestion is in their road network, and they can see on the road network which road intersections get congested first as a seed nodes, and how it spreads, how the congestion spreads in the road network.
Yeah, that's very clear. And just for future work, would you like to explore more?
Yeah, I'm looking now on the robustness of the urban road networks. So when I have the road network as a graph and I start remove the junctions one by one. By remove, I mean when there is accident and we close the intersection. So how it influences on the rest of the urban road
Very
network.
interesting.
This is what I'm doing now.
Very interesting. Good luck with that. Thank you very much.
Thank you. Thank you.
Reena?
Thank you very much, Nagham. Thank you, Assemgul, for the wonderful presentation. Now I'll move on to the next speaker, Jiaying. I would also like to request for the interest of time, please try to keep to the 12 minutes for your presentation. Over to you, Jiaying.
Yes, I see. So let me share my screen now. Yeah, that's my slides, right?
Yes.
Okay, so we're good. I'll start.
Yes, you can.
Okay. Hello, everyone. Thank you for being here. I'm going to talk about the deep reinforcement learning for adaptive traffic controls in sustainable urban mobility. I'm Jiaying. I come from University College Dublin. First, let me introduce myself briefly. I graduated from Beijing Dublin International College in 2020. My major was software engineering. I have my PhD program at the School of the Computer Science in UCD in Ireland. And I will have my first postdoc project this year, start in May, with a local company, TechWorks Marine. Today I will going to talk about my PhD research about sustainable urban traffic management in connected vehicle environments. Okay, that's my research motivation. So it's common problem for us is urban traffic congestion. So for anywhere in US, in EU, it causes significant economic loss and everybody get delayed from the congested traffic. It also causes extra fuel consumption and CO2 emission, carbon dioxide, which is not good for our environment. The sustainable urban traffic is an important aspect for achieve the United Nations Sustainable Development Goals. So it requires us to create a safe, resilient, and sustainable urban traffic, and also reduce the carbon emissions to achieve the net zero, the goals. And we need to develop smart and grey solutions for future city, future transportation. Existing traffic control system for us now, include the adaptive traffic like signal controls. For example, so the traffic signals can adjust by the real-time traffic collected by the induction loops on the road. So the traffic light will be shorter or longer, green light durations for vehicle passing by the intersection. And another method is to adjust the vehicle speed when approaching the intersections. So if the vehicles can accelerate to pass by, it saves the travel time, or it can deceleration in advance to save the fuel consumption and reduce the emission. That's the existing solutions, but now we still struggle with the congested traffic in the urban area. Actually, there is an advanced machine learning method called deep reinforcement learning. It can improve our urban traffic further. Compared with the traditional transportation method, so the traffic will be modeled like or what is the complex urban traffic, about the traffic flow, and the traditional method will provide the fixed, static, rule-based programs to control the traffic signals. It's like congested will has a longer duration, have a fixed range, but reinforcement learning can let the smart agent learn from the environment. So the agent observe the real-time state around the intersection and assign the signal controls and get the feedback from the environment to get bad policies to adjust the traffic signal. So the reinforcement learning provides the continuous learning method from the environment and get the sustainable traffic control. Here is a gap in deep reinforcement learning method for traffic control. So that's my main contributions in my PhD research. For traffic method, it also have the just control the traffic like signals or vehicle speed controls, and even the combination of the two control methods. But for deep reinforcement learning method, there is a gap for the joint control, combine the two important methods, control the infrastructures, like the traffic light signals around the intersection, and also control the traffic flow individual vehicles around the intersection. So we propose the ground control method using deep reinforcement learning or the COTIVs to control the traffic light signals and connected autonomous vehicles. To achieve the sustainable urban traffic light controllers mainly to increase the intersection throughput, reduce the travel time, and also save the fuel consumption to improve the efficiency and reduce the environmental impact. Another way, the CAs can have the better speed to save the fuel consumption. And also, the CAs always keep a safe distance from the surrounding vehicles so it can achieve the better safeties on the road. The challenges for the first work in the ground controls using DRL, we need effective cooperation schemes to train the two type of the agent, and we need to achieve the training convergence after reasonable numbers of training iteration, so it will be stable and reliable to control the traffic. And the method will achieve the comprehensive sustainable traffic goals in efficiency, in eco-friendly driving behavior, in road safety. Here is the system overviews of the COTIVs. So we have the two type of agent. For each of the agent, the DRL framework required the state, action, reward. We combine the two type of agent using the vehicular communications to exchange information between them. So our collaborative methods rely on the state communication, state exchange. As actions for traffic light controller is the battery side to decide switch to the next phase or not. And for CAs for individual vehicles, it provides a proper acceleration to adjust their speed. And for reward, it depends on the surrounding vehicles. For traffic light controllers, it's around the whole intersections. For CAs, it mainly depends on the vehicles on the same road for each CAV agent. So that's the system overviews for COTIV here. Well, I have some simulated scenarios experiments for test the COTIV effectiveness. So from the right figures, that's 6 intersections in Dublin City. Compared with deep reinforcement learning method, like flow CAVs, just to control the CAV speed, and the price light, DRL-based just to control the traffic light signals, and the GLOSA, that's another traditional method in ground controls. Compared with them, the COTIVs get the better results in travel time. It means the traffic efficiency and fuel consumptions to reduce the negative environmental impact. And the TTCs, that means the higher safety. So also, the COTIVs can work well in the mixed autonomy traffic, so with different penetration rates of CAVs, like 100% to 0%. So besides the COTIVs to achieve the traffic urban sustainable the goals, I mean, there are also many challenges to deploy the real world DRL-based applications. So it includes like scalabilities for large scale urban network. And I'm also mentioned about the mixed autonomy traffic. So there are the CAVs on the road with the other human driving cars on the road, and how to have the cost efficient method, and how to be robust, resilient for complex the urban traffic, and also for really use it to the city citizens. Everybody will to require know how to get the trust for the AI powered system. So that's our challenges beside how to achieve the better efficiencies for the urban traffic. So I list some other publications from me during my PhD research. And if you are curious about my solutions, we can discuss later. So that's all from my today's presentation, and any questions are welcome. Thank you for listening.
Thank you very much, Jiaying. Very interesting presentation. Gunny?
Yes, indeed. Yeah, very interesting, Jiaying. Well done. So a lot of interesting topics, very, very relevant to industry as well. The AI trust one I picked up. Yes, absolutely. You know, we use more and more AI in our research, but understanding whether we can trust it, what it's doing inside the box, where's the data come from for training it, for validating. These are really big questions, of course, you know. But I had a question about, you talked about mixed autonomy environments.
Yes.
Of course, you're looking ahead for cabs, but still on the road, cabs are going to be some years away. In reality, you know, there's still a lot of work to be done. Before that, of course, we have the current situation, which is, let's call it no autonomy. So cars that are operated by people like me who are not very good drivers, you know, on the road and whatever. How could your solution already start to influence the way we can impact efficiency and safety? For example, you know, we already have these initiatives called this initiative called GLOSA, which is this green light optimization, how we can sequence the lights better and so on. You know, could we already do something with the work you're doing to improve the way vehicles flow? And what else would we need in terms of data, in terms of the information and so on to do that?
Yes, thank you. That's very good questions for my work. Actually, behind the code-based system overviews, there is scalable strategies to how to choose the efficient CAV agent. Actually, we choose the first CAV vehicles on each incoming road when approaching the intersection, because the first CAVs has the advantages to stabilizing the traffic flows for this road. It means other vehicles, the following vehicles. So the CAV, the first CAV as the agent, so it can collaborate with the intersection traffic light controllers to get better, to stabilizing the traffic flows, get better speed controls, and then it also can save the computation complexities for this system. So any penetration rate of the CAVs can be adapted to using the code-based system for the current traffic situation. Yes.
And did you find in your research there was this penetration rate that starts to make a big difference or not? Is there a tipping point where you see right, CAVs now really do start to influence? Because having, you know, let's say 500 vehicles on the road and 2 are CAVs, you can probably say everyone's going to ignore the CAV. But is there an optimum point of proportion of CAVs versus drivers like me where you start to say, right, okay, now we start making a difference? I don't know if there's a correlation.
Yes. The different penetration of the CAVs is not very determinated for its traffic improvement, because the light CAVs has the little conflicted with the traffic light controllers, but it has a large potentials to get a better coordinations with the traffic light signals. And also we design the traffic light considering about the GLOSA, I mean the green wave. So it considers the incoming and outgoing roads around the intersections. So different intersections region is overlapped between the incoming and outgoing roads. So the traffic light will take the main contributions to control the urban traffic for the global level. But individual vehicles will adjust for just one traffic flow or for a few vehicles which can be impacted to get a better eco-friendly driving behavior.
Okay, very, very interesting. Thank you very much. Yeah, I enjoyed that. Thank you.
Thank
Back to you,
you.
Nagham.
Thank you, Gunny. Yeah, I've got a question. So if there is no cabs on the road, how does the COTB operate?
Sorry, could you repeat? I didn't.
Just I want to know what is the penetration rate of the cabs, and if there is no cabs on the road, how does COTB operates? Yeah.
Oh yes, the different penetration rate, I simulated the mixed autonomy by just with a ratio. It's randomly distributed to simulate the real world urban traffic. So we can to test the COTB ways can be effective under whether the city ways is really approaching the intersection or just arriving on the road. So in the connected vehicles, so the vehicles information can be collected very accurately. So the different penetration rate of CAF will be helpful beyond the traffic light signal control.
I think that for me, also the similar question was, if there's zero penetration rate,
Yes.
meaning zero cabs, what happens? There's no cabs, zero.
Yeah. If no cabs, the COTB ways will be like just the traffic light control as a single control. But our method, it shows like slightly better than the press light as the state of the art, the DRL-based traffic signal control. So the COTB ways can be more generalized for the mixed autonomy from the no zero curve or to the fully the fully autonomy traffic. Yes.
What about scalability? So you showed us a scenario where you looked at a road, but what about scaling up and just having in like more larger scale urban scenario?
Yes, I just showed like the 6 intersections in Dublin scenario. I have tried like 1 square kilometers consist of the over 30 significant intersection and other unsignalized intersection. That will be a large city region. And this is like a distributed method. So if you use edge computing, other communication method will be adapted to the large scale urban network. So for now, I just test a sub-region for the whole big city.
Good luck. Thank you very much. Thank you.
Thank you.
Reenu?
Thank you for your questions.
You're welcome.
Thank you
Reenu?
very much. Thank you, Jiaying, for the wonderful presentation. Now we'll go forward to the next speaker, Reem Bashir. Welcome, Reem, for your presentation.
Hi, thank you a lot. Let me share the screen. Okay, good afternoon, everyone. My name is Reem Bashir, and I'm glad to be here with you today. I will present my research on evaluating intrusion detection system for in-vehicle network. With the increase of connectivity of modern vehicles, ensuring robust cybersecurity measures become critical to support the resilient. One key security solution is intrusion detection system. However, evaluating the effectiveness of IDS remain a challenge. This is where my research comes and aim to address these issues by developing a systematic evaluation framework. So to guide you through this topic, I will cover a brief introduction about myself and then the aim and objective of my research. After that, I will try to put like a story of how we got to this research by first have an overview of the in-vehicle network and then the automotive cybersecurity challenges of these networks. And after that, the role of UN Regulation 155 in ensuring cyber vehicle security. And finally, the significance of the intrusion detection system. All this will bring us to the need for an effective IDS evaluation framework. So let's start with a bit about my background. So I'm currently a cybersecurity project engineer at Hoiva Myra with 6 years experience in automotive cybersecurity. I hold MSc in cybersecurity and digital forensics and currently pursuing my PhD at De Montfort University, focusing on automotive IDS evaluation. My work revolves around threat analysis and risk assessment, which is known as TARA in the ISO standard, ISO SAE standard 21434, and also doing verification and validation to test the product cybersecurity measures and some R&D as well. So this research is essential as the cybersecurity threats in the automotive sector continue to rise. So now let's move to the main focus of my research. So the aim basically from my research is to develop a robust evaluation framework to assess the effectiveness of the IDS in in-vehicle network. This will help in enhance the cybersecurity resilience, support the regulation compliance, and improve the reliability of the intrusion detection in in-vehicle. So basically, to achieve this one, I focus on designing and implementing a systematic evaluation framework, and then I will be validating the proposed framework to ensure its practicality and effectiveness. But before we dive into the IDS, we need to understand the story behind it. So now let's talk about how in-vehicle networking functions, basically. So modern vehicles rely on a complex network where they send like information between ECU. Think about the ECU as like the brain that sends like commands to manage the functions such as like engine control or braking. And now we start to see like there is more demand for like high performance computing ECUs. Why? Because now there's the consumer is expecting more, and they're expecting luxury, comfort, and safety. And now with all the V2X and with ADAS information as well. So we need like a high performance computing ECUs so that it can manage all these data. There's different communication network that used to send like messages between the ECUs. And most common and well-known one is control area network, which is known as CAN. So basically it's used in vehicle motion and body controls. However, for the safety critical application, FlexRay is more common used. Why? Because it's using it have like a time sensitive aspect. Another one is MOST, which is used to handle like infotainment, but now it's not being used that much and be replaced by automotive Ethernet. This will bring us to the automotive Ethernet. So with the increase of the connectivity of the vehicles like V2X and even ADAS, there is a need to high-speed data exchange. This is where automotive Ethernet come, and it's the latest network has been added to the in-vehicle network. And now we start to see that they're using automotive Ethernet as a backbone for the network. And in the future, it's going to be more like this one. So yeah. While these networks enhance the connectivity, they lack the security features, basically, which introduce like the security risk. That brings us to our next slide. Yeah, so there is a growing on automotive cybersecurity attacks and threats, and as the vehicle, we said like it become more connected, the attack surface expanded, which is increasing the remote cybersecurity attacks. As I said, like many in-vehicle networks, like the built-in security mechanism, making them like vulnerable to, for example, unauthorized access or even manipulation. A well-known cybersecurity incident is Jeep hack attack, where the attackers like managed to remotely control the vehicles and manipulate like the braking and the acceleration. Another good example is the Tesla Model S attacks, where the researchers managed to do like keyless entry attacks on them, and they managed to unlock the vehicle and start it. According to Upstream's cybersecurity reports, so basically the cybersecurity incidents increased by 50% between 2019 and 2023. This highlights the trend that we need like stronger cybersecurity measures, and we need industry-wide standards and regulation to protect the vehicles. Such standards and the well-known now standard for automotive cybersecurity is ISO SAE 21434, which was published in 2021. But the most important one is the UN Regulation 155. So the UN Regulation 155 was introduced in 2022 by UN, and from March 2023, the vehicle manufacturer now are required to, first of all, conduct a risk assessment and security testing to identify this vulnerability. Second of all, they require to implement like continuous monitoring and software updates to protect the vehicle throughout their life cycle. How are they going to do that? By detect and respond to the cybersecurity attacks, as shown in the picture. So one of the most important tools to detect the attacks throughout the life cycle is intrusion detection system. And this brings us to the IDS. So now let's explore what is the state of in-vehicle IDS. So before that, what is IDS? IDS are like cybersecurity mechanism, which is designed to monitor and detect cybersecurity threats in-vehicle network. So there is a large research on the in-vehicle network IDS and several market solutions such as AutoCrypt IDS. Unlike traditional IT IDS, the in-vehicle IDS overcome some unique challenges, such as for example, limiting computing resource and low memory capacity of the ECUs. Another one, in the automotive cybersecurity, we focus, it's really important to focus on the safety damage, as well as the operational, financial, and privacy damage as well. But this will bring us to the need for the real-time detection to prevent safety critical failure. Given this problem, IDS must evolve to keep up with the changing in the threat landscape. The evolution of in-vehicle IDS. So historically, in-vehicle IDS focused on CAN network only, but now after the automotive architecture evolved, we have seen the shift towards automotive Ethernet in the last 2 years. So more in the last 2 years, more and more research has been done on automotive Ethernet as well, IDS. And since 2020, as you can see in the chart, the industry has transmitted from traditional machine learning IDS to AI anomaly-based and even hybrid IDS, which offer a better real-time adaptability and scalability. So despite all of these advancements, evaluating the IDS effectiveness remains a challenge. So the current state of the IDS evaluation presents several challenges. One of the most important one is with the increase of the IDS solutions, vehicle manufacturers struggling to identify which best IDS for their system and how to evaluate that one. The other one is with this lack of universal standards, the absence of the industry-wide evaluation framework, make the comparing IDS solution very difficult. Also, there is a limited research about the evaluation framework, only found 3 papers propose a framework evaluating, and it was only for CAN-based IDS. So based on all the above come my proposed framework, which is aimed to fill this gap, a standardized in-vehicle IDS evaluation framework. My proposed framework ensures that the IDS solution align with the UN Reg 155 and also assessing the detection accuracy, how effective the IDS detect threats throughout the different network. Also, the processing speed, ensuring that the real-time detection without any delay. Another one is the resource consumption, measuring the IDS CPU and memory usage, basically. This framework provides a structure and standardized ways to evaluate the IDS and enhance the vehicle cybersecurity. We are currently in the design phase, as shown in the chart below. So this conducts my presentation. In summary, as vehicles become increasingly connected, cybersecurity threats continue to rise. While intrusion detection system IDS are essential, their evaluation remain inconsistent. My research aims to bridge this gap by developing a robust in-vehicle IDS evaluation framework that align with the industry standards like UN Regulation 155. Thank you again for your time, and I would be happy to answer any of your questions.
Thank you very much, Reem.
Yes.
Yeah, thank you, Reem. Very interesting. And yeah, it's again a very important topic in the automotive world. In your evaluation framework, are you also looking at verification and validation methods for IDS evaluation?
Do you mean validation for the framework that we're going to create?
So within the framework, because you're going to, let's say you have multiple IDS solutions,
yeah,
and you have to evaluate, I'm assuming you're evaluating them.
Yeah.
So there's a framework with evaluation, but within the framework, is there also elements of real world testing, and are they standards based or are they additional?
So we're gonna
standards?
we're gonna use like a real world testing. So basically, we're gonna use a data set from real world, which data set we're gonna be creating by ourselves, so that we will include like more data set, because there's a limitation in the data set right now. So basically, we're trying to create our own data set where we include like Ethernet, CAN, and multiple network together having attacks on the same time. So we're gonna use these data set to do the evaluation and verification as well. So I hope that answers your question.
Yeah, that's good. Yes, and I had one follow-up question. So the whole, as you know, automotive industry is doing more and more model-based development and evaluation, especially of networks and the ECU architectures. So there's companies like DSpace and others. They have these REST bus. So basically, they model the vehicle and don't rely on real systems. Is that something that you've come across as being an important area or a transition happening? Are there more companies looking to do more of this modeling? We talked about CAN, Ethernet, and so on, and do simulation-based evaluation versus real-world evaluation.
A lot of them, they're doing like simulation-based evaluation, but yeah, I'm not sure if they're going to do like real-world evaluation. However, there's a lot of what is called solution market. They claim that they do like a real-world evaluation, but when I tried to contact them, I couldn't find like any answers, and they didn't give me any data. So I cannot say like for sure, yeah, they're going through to do like a real-world evaluation. So yeah.
Great. Thanks very much, Reem. Yeah, very interesting. Thank you.
Yeah, thank you, Reenu. Thank you so much for all the questions that you've been challenging our speakers with. I think they really benefited from your knowledge, and these questions will make them think and just maybe apply. For Reem, I've got a follow-up. Actually, for both the questions that you asked her, I need to do a little bit of just more expanding. So the first question for you, just why is a standardization evaluation framework essential for assessing the effectiveness of in-vehicle IDS?
So basically, the main important reason is like because we said that there is increase of the automotive products. So the manufacturers need to have like something that where it can evaluate for them like which IDS to use basically for their products. Another one is like when they have this like evaluation framework, then they will go to the UN. They will be like more. They will help them more to evaluate like that, verify that they have been complied with the regulation 155. So this is another one. Although there is, yeah, as I said, research on that topic, but they are like inconsistent, and they're using inconsistent method and various data set, and also they use like narrow and focusing only on the CAN network, but it's not like focusing on other network as well, like automotive Ethernet. So yeah.
Okay. No, thank you for this. Now it's better for me to evaluate the whole thing. Just my other question is just if we are thinking of a universal IDS evaluation framework, what are the challenges? Again, I will ask a very similar question, but what are the challenges here?
Yeah, so mainly now one of the challenges is the data set. So that's why we're trying to create our own data set. There is a limited data set, especially for CAN. There is a lot for CAN, but there is a limited for Ethernet or Ethernet with CAN or like multiple in-vehicle network within the same data set. That's why we're trying to create our own data set right now to do the evaluation and evaluating the IDS, basically, verification of the IDS. Another one is like how to detect like the accuracy of like the resource consumption, because in the ECUs, it's not only the IDS who is going to be like work or trying to do the consuming stuff, like other processes will be also at the background. That's why we're trying to use something like a simulation like Canoe or VectorBox even to try to see like if it's possible to do that. And try to get like the accurately detecting the resource consumptions, basically. So yeah.
Looking forward to see your result and hopefully your publication. Thank you very much, Reem.
Thank you.
And back to you, Reenu.
Thank you very much, Nagham, and thank you, Reem, for your wonderful presentation. I think now we have completed the main presentations for the event from our speakers, and now we're looking forward to a presentation from Gunny. I would like to take a second before that. We want you to share your feedback about this event. I will just share a screen now, just for 30 seconds, where we can scan the QR code and give us our feedback for the event, so that we can have better presentations next time. So this is a QR code. I'll just leave it for 10 seconds and then we go on to the next presentation. All right, now, hope everybody got a chance to scan the QR code for the feedback form. Now I welcome Gunny for your presentation. Over to you, Gunny.
Reenu, thank you very much. I'm just going to share my screen. Okay, here we go. Okay, just check you can all see that. Yep.
Yes.
Okay, so first of all, I just want to congratulate all of the speakers for a fantastic job in presenting today. I can say that every one of your topics is very relevant to the industry, not just the automotive industry, but the broader transport industry. I could see the depth of knowledge and expertise was excellent. I'm very proud on behalf of AESIN to be supporting this. And we're really looking forward to also collaborating with all of you for the AESIN conference, which I'll mention in a minute. So let me tell you what AESIN is. AESIN stands for the Automotive Electronics Systems Innovation Network, and it's been around for about 14 years. And part of that has been how we engage industry and academia to go and innovate next generation of systems. So the importance of research is critical in what we do. And we really stand for building communities, which is, bringing people together to talk about relevant issues, strong collaborations, so opportunities to research and innovate together, and thought leadership, which is looking ahead to say, where are the challenges and where are the opportunities for the country to go and develop, okay? So I'll just talk very quickly about a bit of the history and a lot of things you've touched on, many of you in the call, and then I'll talk about what we do in AESIN to address those, and then an invitation for you all to join us this summer. So here's just a very simple graphic of this evolution of electronic systems. Reem, you touched a little bit about the complexity of in-vehicle networks. Well, actually, it started right in the 1970s with some very simple control technologies, and as in the sort of the first 10 years up to the 80s, we started to see some of these what we call multiplex systems, these in-vehicle networks for communication. But within 10 or 15 years, there was this rapid acceleration of software, and we talk about the CAN networks, which is really foundational in enabling all of this. And as software increased, we start to see some of the challenges. There are software bugs, this unintended acceleration type thing. We talked about the Tesla challenges with their connectivity solutions. But Tesla, as an example, was a real disruptor because they came in with a software-based, technology-based vehicle architecture that sat on a car that drove you up and down on an electric platform. Whereas traditionally, it was, we had these wonderful cars with engines, and then you put some technology on them to try and improve them or give a better experience. This has turned upside down. However, the traditional vehicle management, there's hundreds of ECUs, being used across the industry. The large vehicles use over 100 ECUs per vehicle, smaller ones are 50, 60 ECUs. But with all of this comes complexity, software challenges, hardware challenges, all of the things we've touched on today. And now with more connectivity, and thanks for bringing all of this up, we have some new challenges. Along with this supply chain issues, some of you may have heard about the semiconductor shortage, the chip shortage during the pandemic. These are real issues. These are real geopolitical situations which affect the industry globally. And now we see more transition and more disruption happening across the industry. So just on this slide, we touched on the size of the industry. These are just some figures from markets, but what they show is in the next 10 years or so, we're looking to grow. It's exponentially, maybe mathematically, maybe the wrong term, but significant multiples of growth in terms of the market. So the ECU market you see now, we're projected to be 28 to 35 billion dollars. By 2033, it's 178 billion. Similarly, with the different types of systems, we talk about electronics, infotainment. Many of these will be connected. There's a growth rate predicted there over the next decade as well. So we're seeing this huge explosion in the industry, and for the UK, we have to also be part of this story to understand where we create research, innovation, and industry. AESIN, I call this the heartbeat. We have 6 special interest groups where we encourage researchers, academics, and industry in particular to come together and talk about some of the challenges and opportunities. I won't go into detail. Software-defined vehicles is really about this new, I call it a paradigm, where you have the vehicle and the cloud is really one architecture now. You can't separate them. You have to really consider the design from the box that sits on those 4 wheels to the Amazon web servers and the Google workspaces. It's one continuous architecture. So the industry is shifting to start to think about actually how do we now organize ourselves to do this. And this is the world of the software-defined vehicle. So many of the things the speakers touched on will start to impact the way the software will define how the vehicle is designed. The perception sensors for CAM, this is an understanding that as we move towards more and more connected and autonomous mobility, the role of sensing, perception, AI, and understanding what the road is doing and what the environment is doing will play more and more of a critical part in how the vehicle is controlled, because we won't be touching steering wheels anymore, but we will rely on the vehicle deciding. And so sensing and perception is going to be a critical area. Security and resilience, I think we all are pretty relevant in that space here today. Again, a huge topic, so many unknowns, so many new challenges coming. And, thanks again to the speakers for bringing some of those out in your talks. And we have to keep talking with the industry about new ideas and new thought around what we shift there. Research and innovation is actually one of our groups led by Swansea University, looking to see where future research should be and how we then link it to industry. That's a key group for us to make sure that the academic input is relevant. Systems engineering is very much around a connected world, the impact of vehicle data on the infrastructure and vice versa, and also challenging some of the business models around actually why would a car company want to give their data to a road operator? Yeah, if there's no money involved. The road operators want free data, car companies want to make money from data, and then you have this conflict of interest. But the overall good is about the road safety, road efficiency, network operator efficiency, and so on. So there's an area there where we're working with ITS UK as an example to tackle some of those questions. And the last one is power electronics and control systems, less relevant to this group here, but nevertheless, an important understanding that as we move to electrification, electric vehicles, we have to have a base of technology and control. And this all fits into how you use, again, over the air. We have companies developing battery management systems, but a lot of the development is done on cloud-based architectures before they even deploy on a vehicle. So I won't dwell any more on what we do, apart from, again, there's another QR code here for you. I invite you all to join us for our conference, which is titled The Future is Electronic, From AI to Power, on the 19th of June. This will be held at the British Motor Museum, which is in Gaydon, right next to the Jaguar Land Rover headquarters. And for all academics, all researchers, the event is free. It's normally £100 entry or £99, but this is free for you all. And we invite you to join us. And just to announce that we have a special session where we will take the best speakers from today and provide them a space to present at the conference on the 19th as well. And Nagham and I are working very hard to shape that session as well. So please feel free to take a picture of the QR code. You're all invited. Spread the word. You know, as I said, it's a free entry to academics and researchers. If you have colleagues you think are interested or researchers, please share this with them as well. And we look forward to seeing you then. With that, thank you very much, Reenu, and thank you very much, Nagham. I'm going to now close my screen and hand back over to you.
Thank you. Thank you so much, Gunny. It's very interesting, and thank you very much for the generous offer. We are very blessed to have you in this 14 early career talk with us. We benefit so much from your knowledge, and also from hopefully also still our speakers. They will have the benefit of also joining and just having a great time networking and showing their work and communicating just for further research. Thank you so much. And also I would like also, I don't want to forget the great work Reenu did with us in moderating, and I don't want to forget also Professor Kaya. Just he really worked so hard with us to select the speaker. So just here, thank you everyone. Back to you, Reenu.
Thank you very much, Nagham, and thank you very much, Gunny, for the presentation. Now we are coming to the closing of this event, and I would also share my screen once again for the QR code for the feedback. Please send your feedback, and happy International Women's Day, everyone, and thank you very much for making this event a great success. Thank you. With this, I think we can conclude the event. Nagham. I think Nagham is not available at the moment, but thank you everyone again. So we'll conclude this event. Thank you everyone for the presentations and making this a grand success.
Thank you. Thank you so much for organizing this event.
Thank you.
Thank you, and
Thank
well
you.
done again to everybody. Thank you, Reenu. Well done. Thank you.
Thank you, everyone.
Bye.
Thank you to all the speakers.
Bye
Thank
bye.
you.
Have a nice weekend.
You too.
Thank you.
Have a nice weekend, everyone. Thank you. Bye.
Bye.
Sorry everyone, I don't know what's happened, but just we lost the connection. Thank you everyone for joining. Bye. Thank you.